All right, let's see here. Let's continue where we were. Um, we can continue solving for z by, let's just get z by itself on the left-hand side. So I will well, you know what, actually, um, since there's only variable terms on the right-hand side, I'll just get all of the variable terms on the right-hand side by subtracting 4z. 20 minus 96, those combine to be negative, oh, what is that? Negative 76 equals 4z. And then we can divide by 4. How many times does 4 go into 76? I'm not sure. So 4 goes into 7 one time. 1 times 4 is 3. 7 minus... 1 times 4 is not 3. 1 times 4 is 4. 7 minus 4 is 3. Then we drop down to 6. 4 goes into 36 9 times. So we get 19. Negative 19 equals z. All right, very good. We solved for z. So, yeah, the numbers were a little bit large there, like 76. I even had to do long division. Um, the numbers were large because we didn't multiply by the least common denominator. I actually want to see what it looks like if we do multiply by the least common denominator to see how much easier it would be. So let's go ahead and do that just very quickly. I, I enjoy looking at these things here, but I don't have time. I don't have time to do all that. So we'll do it. We'll do it right now. And let's see. The LCD is actually 8, right? So we'll multiply by 8 on both sides of the equation. That will come out to multiplying each of the terms by 8. In the first term, the 8s will just completely cancel. And so we get z plus 5 minus 8 times 3, which is 24, and then equals 2z. And so if we subtract z on both sides, notice how nice this is. 5 minus 24 is negative 19. 2z minus z is just z. And we have our answer. Numbers were a lot smaller, didn't have to do long division. So if you can find the LCD, the least common denominator, multiply by that. It will, be easier in the long run. Okay. But if you can't find the LCD, you can still do it with just any denominator, as long as it's a common denominator. All right. Let's finish this up here. M minus 7 divided by 20 plus, 1.3 equals negative 2.1. Solve for M. Okay. Well, this is a funny problem here. Um, there's decimals and there are um, fractions. So let's go ahead and try to get rid of the decimals first. Um, Let's see here. We learned a little bit about multiplying in one of the videos, multiplying by powers of 10. That moves decimal places over by, 1 or 2 places, depending on how many zeros your power of 10 has. And so in this case, since we have decimals that go to the tenth place, we should multiply by 10 to move all of the decimal places over one place. So let's go ahead and do that. And I'll do it by, I'll multiply by 10, but notice that the least common denominator in this problem is actually 20, because there's only one denominator and it's 20. So multiplying by 10 will not be enough to get rid of the fraction as well. We really need to multiply by 20, but we'll worry about that in just a little bit. Let's see here. So let's multiply by 10 to worry about the decimals first. When we multiply by 10, oops, there's a 10 over here. We're going to get 10 times m minus 7 over 20. We could do a little bit of simplification there, but I'll just wait. 10 times 1.3 moves the decimal place over one place to get 13, equals, and then we move the decimal place over to get negative 21 on the right-hand side. So now we still have a fraction, and we said we wanted to multiply by 20 to get rid of that fraction. We've already multiplied by 10, so we just need to multiply by 2 now. If we multiply the entire equation by 2, because really this fraction is, if we simplify it, 10 divided by 20 is the same thing as 1/2. So now to get rid of that 1/2, we need to multiply by 2. We'll multiply by 2, and notice that 2 would have made the numerator factor there a 20. The 20s would cancel, so this is going to work. We multiply by 2, and we have that 2 cancels with this 2, or the 2 times 10, the 20 cancels with 20, however you want to think about it. And then we have m minus 7 plus 2 times 13, which is 26, and 2 times negative 21, which is negative 42. So, combining like terms, negative 7 plus 26 is positive 19. And then if we subtract 19, m equals negative 50, 61. Negative 61 is our answer. All right. Very good. We could check each of these answers if we really want to. Um, let's check this one. Why not? So we're saying that we've solved for the variable m. To solve means to find the solution, and a solution is a number that can be plugged into the original equation to get a true statement. So if we plug in the negative 61 in for m in the original equation, this should be a true statement. Now I have to simplify to see if it is true or not. Negative 61 minus 7 is negative 68. Negative 68 divided by 20, that can reduce by 2. So I'll reduce by a factor of 2 to get 10 on the bottom and negative 34 on the top. Now, negative 34 divided by 10 would just move the decimal place over one place to the left. And so this would be negative 3.4 plus 1.3 equals negative 2.1. And if we add these two decimals together, one of them is negative, one of them is positive, so I should take 3.4, subtract 1.3. That is 1, 2, 2.1, and then I keep the sign of the bigger number, or the more massive number, which is the negative one. And so negative 2.1 equals negative 2.1. This left side's simplified to negative 2.1. And so I do get a true statement, which means that negative 61 is in fact my solution. Okay, I've just verified the solution there. Cool. We're going to talk more about solutions in problem number 5, which is coming up next. How many solutions can a linear equation have? That is the topic of problem number 5. All right, and we'll do the last one here. 12p plus 9.6 equals 3. This equation has decimals. Similar to the fractions, the decimals are really just, you can write them as fractions. So we can write this as 12p plus 96 over 10 equals 3. So notice that the least common denominator here is 10. So I can multiply by 10 to get rid of all of the fractions. Yep. And so in a similar way, I could have really just started this problem by multiplying by 10 to get rid of all of the decimals. Because we're in the 10th place, we should multiply by a power of 10 that has just a single zero. That's 10. All right, so when I do that, let me go ahead and move this fraction thing. When I do that, I get 12 times 10 is 120p. 9.6 times 10 is just 96. And then 3 times 10 is 30. I can subtract my 96. And so I get 120p equals negative 60, oops, 6. Yep. And then divide by 120. So p is equal to, these both have a factor of 6. So I'll divide by 6 on the top and bottom, negative 11 over 20. And that's my answer. And I guess I could be checking. I have the answers here. Negative 11 over 20 for problem number 4J. 4J is negative 11 over 20. Yeah. Okay, very good. That is problem number 4, solving equations for some indicated expression. All right, we'll see you in the next video.